Assalamu alaikum, welcome to Study On. This is Samia Aziz and you are here with me to learn about operations research. In our previous lecture, we learned about its historical background and the operation research process, what actually operation research is, how much important the subject is, in which field. We learned about the modeling types. We learned that how we can apply this conceptual work or problem solving approach to our daily lives, to businesses, to our daily lives, and more than that. So this subject has got a great significance. We discussed all theoretical work, but today we are going to learn a lot more stuff about this subject, and we are going to start with chapter number 2, which is linear programming. So this is chapter number 2, and in this we will discuss and we will learn about analyzing the problem, and what else we will learn is that how to model we will learn how to make LP equations and how to model it. We will also learn that how to take feasible points that will help us to attain, how to take out optimum solution. We will learn about how to plot on graph, by which we will be able, after plotting, we will be able to take out the feasible points, and these feasible points will help us when we will put in the objective function, we will be able to find out the best suggestion for a firm, for the firm that we are working for. So these are the things that we will be doing in today's lecture. All right, so this is just an overview of what we are going to achieve through this lecture. So let's get started to the problem that we have to discuss. So here comes a problem which is regarding a company that is producing pants, right? The name of the company is Ready Mix Company, and this company is specialized in producing pants. So let's watch and understand the problem criteria of this company. So Ready Mix produces both interior and exterior pants. So two types of pants they are producing. The one is an interior pant and the other is the exterior pant from two raw materials, which is M1 and M2. Okay, so for production of this pant they need two materials, M1 and M2. So following table provides the basic data. Let's see that there is exterior pant, there is interior pant, and we have maximum daily availability of raw material in tons, right? So the measurement is done into the tons. Now for if we look at raw material 1, so which is called as M1, to produce exterior pant, we need 6 units of or 6 tons of raw material 1. Okay, and to produce interior pant, we need 4 tons of raw material 1. Altogether, the daily maximum availability of raw material 1 is 24 tons. Now, the production, whatever the production we are doing with the raw material 1 should not exceed at any case more than 24 tons, which it means that the production should be inside 24 tons availability, which is told by the company. All right, if we look at raw material 2, it also has a limitation of 6 tons, right? Total availability is 6 tons. Now whatever we are going to produce, we have to produce in that limit. So if you see that raw material 1 is also needed by exterior paint production by 1 ton, and 2 tons are needed for the interior paint. Alright, so maximum daily availability what we have is 6. That simply means that our production must be inside the limit. It should not exceed, because if we will exceed the limit, if we will exceed somehow, so we will be out of the resources, and want that. Okay, we want to be in our limit so that our resources are available and our production is done in a maximum efficiency or efficient manner. Now, company has also told us about the profit making criteria. So you see that the profit per ton is represented as 1,000 per ton, dollar per ton, right? And they have told us that the profit they are generating from exterior paint is 5, which is multiplied by 1,000 per ton, so it becomes 5,000. So daily maximum profit that they are earning from making of the exterior paint is 5,000, and here if we multiply 1,000, which is per ton, so there are 4 tons of paints, 5 tons of exterior, 4 tons of interior, so we will be getting 4,000 of profit from the interior paint. So these are the two situations that are given by the firm to us. More information is given regarding market survey, which is indicating that the daily demand for interior paint cannot exceed that for exterior paint by more than 1 ton. So whatever the production of exterior paint is, whatever the tons you are making of exterior paint, the interior paint is going to be always less than 1 ton by exterior paint. So it should not exceed more than exterior paint by 1 ton. So it will be always less than 1 ton. So this is a market restriction which we have gathered from the market. Okay, so they have told us that this is a market information, that in the market the production of the exterior paint is always going to be less than the exterior paint. Another restriction is told, which is regarding the demand of the interior paint, which is interior paint is 2 tons. Daily maximum demand for the interior paint is only 2 tons. So this is the demand restriction, right? This is the market restriction, this is the demand restriction, and these both restrictions relates to the raw material restrictions. We call it a raw material restriction. So altogether we have got here 3 restrictions. Ready mix want to determine to optimum best product mix of interior and exterior paint that it maximizes the daily profit. So we have to tell the company about what product mix they should make to reach at the maximum profit making place. So by mix we mean how many units of interior paints and how many units of exterior paint they should make that they reach at the maximum profit making criteria or situation. So this is all about analyzing the question. Now we are going to learn that what are the series of steps, as we have discussed already in the slides. So we are breaking down this question now into the series of steps. So step number 1 is identify the decision variable and represent them in mathematical symbols, or represent them mathematically. Now because variable determination is important, or denoting them with variable is important, because we cannot talk about interior pen and exterior pen with name. We have to assign them with some variable. So that's the best way to go with. So we are denoting the both pens, interior and exterior pen, with the variable. So now xe variable we are using for the exterior pen, xe. You can also simply denote them with x1 and x2, or a and b, or y and z, whatever variable you like to denote them with. So here I am using xe as the exterior pen and xi as the interior pen. Okay, so we have denoted the variables. Next, step is that we are going to identify the objective function. Now, as I told you that the company has either maximization or minimization function. So here the goal of the company is to maximize the profit, as they are asking that what amount of interior and exterior paint to produce to reach at the maximization of the profit. So the profit from exterior paint, as we saw in the table here, is 5 per ton, right? 5 tons. So multiplied by 1000, so 5000. So if we are simply taking that 5 xe in thousand of dollars daily profit, and profit from the interior paint 4 xi is 1000 per ton daily we are earning from that. So let's suppose that Z represent the total daily profit in thousand of dollars. So the objective of function of the ready mix can be represented as follows. We are representing maximize Z. Z represents the profit function of the ready mix. 5xe, 5 is the profit that we are earning per ton from exterior paints. This is the exterior paint, and 4 is a profit that we are making from interior paint. Now we don't know the number of units, so company don't know this section. Company needs to know about this proportion, that what should be the proportion that they should make in last, and they will be multiplying it with the 5, so they will reach to the final profit, whatever the profit will come. So we have to drive out these both values. Okay, either you can represent them xe, xi, or x1, x2, it's up to you. Step number 3, identify the constraints or restrictions and represent them mathematically. So I told you that first restriction we have about the material constraint. So raw material constraint was this equation. This is equation number 1. This is equation number 2. So recall that the daily production of both the paints should be less than the maximum daily availability of raw material in tons. Okay, so we know that we have already learned this from the table, and now we are simply representing the equations 6xe, because here xe represents the exterior paint, 6 represents the material 1 restriction, right? So 6 tons of material 6 tons of material 1 for exterior paint plus 4 tons of material 1 for interior paint, and the daily maximum availability is 24 tons. This is the M1 limit. M2 limit is XE, which is 1 ton for exterior paint. So there is a 1, consider 1, and plus 2XI, which simply means that 2 tons of material 2 for interior paint, and 6 represents the total maximum availability of the material 2. So this is a M2 restriction. So equation 1 and equation 2 are ready. Now we have to make another equation on behalf of constraint number 2, which is based on the market. So the demand of interior paint should not exceed exterior paint by more than 1 ton. So we can write this as XI. The interior paint will always be less than or equal to exterior paint plus 1, because they say exterior paint more than 1 ton. So exterior paint will always be more by 1 to the interior paint, or in other way we can say that XI minus XE less than or equal to 1. In other terms, we can also write it XE minus XE plus XI less than or equals to. So we call it equation number 3. And now for the equation number 4, there is a demand based constraint which says that the maximum daily demand of interior paint is not going to be more than 2 tons. So we have put a limitation that XI, the interior paint production, is less than or equals to 2 always. So either it is equal to 2 or it is less than 2, but it is never going to be more than 2. So this is our equation number 4. Constraint number 4, which is about non-negativity, which means that the exterior paint and interior paint are never going to be 0. They are always greater to be greater than 0, because we are going to provide in the end the company some information that how many units of interior and exterior paint they are going to produce. If we are not putting this restriction, then it means that the 0 will it will lead to 0, which will say that the 0 number of exterior paints and 0 number of interior paint, which is going to be an invalid answer. So that's why we have to put this restriction, so that we will tell them a valid answer.